Hello everyone, this is Mohammad Hamza Javed and welcome to another video. In this video, we are going to talk about Amazon SageMaker. If you are an aspiring machine learning engineer, this is the AWS service that you must know about. It's going to make your life a lot easier. Let me make SageMaker easier for you to understand. Amazon SageMaker is a fully managed service, which means that you don't need to worry about any server instances that spin up in the background. It lets you build, train, and deploy machine learning models, and it's the backbone for doing machine learning on AWS Cloud. Now let me share a personal experience. I remember training a deep learning model on an i3 laptop, and it literally took days to train. And it was an iterative process. My laptop used to get heat up while training TensorFlow models. Those of you who have already trained a couple of models on laptops, you know what it feels like. But with SageMaker, you can leverage AWS Cloud and let the model get trained on the cloud. You can choose from a wide variety of powerful instances ranging from T2 medium instances, smallest possible, to very, very powerful instances with GPUs. Now let's discuss the three stages of Amazon SageMaker. The first stage is build. In build phase, what you do is you generate your dataset with ETL process. This includes labeling and pre-processing dataset. You do feature selection and feature engineering. Next, launching a SageMaker notebook. As soon as the Jupyter notebook is ready, you can start data exploration and pre-processing. And the best part is, SageMaker lets you choose the size of server you want to run your notebook on. We'll briefly discuss the compute types in the upcoming slides. You may also connect to Amazon S3 for storing and retrieving datasets. Once the build stage is done, our pre-processed dataset will reside on an S3 bucket. Now you can choose from a wide variety of built-in algorithms and start training the model, or you can BYOA, which is bring your own algorithm. Model training is not as easy as it sounds. It's laborious, mundane, iterative process. You need to evaluate the model and tweak the hyperparameters, then train again and see if it performs any better. The train phase includes launching a fleet of EC2 instances for training. It's the best part. You can choose not only the type and size of server you want to train your model on, but also the number of instances you need. So you can have many instances to train your model at the same time. On AWS Cloud, there are a couple of types of instances that you can spin up. The very first type is T-type, which is the smallest possible option. Then there's M-type. It's slightly larger with more memory and cores. Then we have got C-type, which is compute optimized instances. And lastly, we have P-type, which is GPU enabled instances. You can literally start the servers with just one line of code, and they will automatically shut down when the training is complete. So here's a suggestion. You don't need to spend thousands of rupees on purchasing a GPU enabled laptop just because you want to train a model. Create an AWS account and leverage the power of cloud instead. Unless you want to use machine learning as an excuse for buying a gaming laptop. And once the training phase is over, you can store the trained model on an S3 bucket. Stage 3, deploy. Obviously, when you're done training, you would want to deploy your model somewhere. Once your model is trained and you're satisfied with the results, you can deploy the model to SageMaker endpoints. You can choose to serve predictions in real time or batch. We can use just one line of code to deploy our model to production and have it serve predictions through HTTP APIs. We can consume it in mobile or web application or simply consume from a serverless function. So these were the three stages where SageMaker can help us. Now let's discuss the benefits of Amazon SageMaker. SageMaker lets you entertain different hardware requirements. For example, ETL is mostly CPU and memory intensive. Training a model requires powerful GPU machines. Inference or prediction is not that compute intensive. So you can have different machines for different stages of a machine learning workflow, and they are all fully managed by AWS. You can train your model remotely with the power of AWS Cloud. You can distribute the training and tuning over several instances to speed things up. SageMaker supports TensorFlow and Apache MXNet out of the box, and engineers don't need to worry about managing different servers. One of the coolest features of SageMaker is automatic model tuning. The automatic model tuning service performs hyperparameter tuning using Bayesian optimization. Tuning hyperparameters tends to be painfully slow, but SageMaker reduces execution time significantly by distributing the compute workloads across many instances. So there are three ways to access or control your SageMaker environment. Number one, AWS Management Console. It's the AWS website that you usually sign into to interact with all the other services. Next is Boto3 and SageMaker SDK. Both of these are Python SDKs, and you can call functions to either train or deploy your model. Number three, SageMaker Notebooks. These are the same Jupyter notebooks that we discussed in the previous video, but they are just managed by SageMaker now, which means that you don't need to worry about the servers these notebooks run on. SageMaker handles it for you. So that's about it from this video. I have added a couple of links in the description below that you might want to look at. And if you know something interesting about SageMaker, please mention that in the comment below so others can learn from it. I hope that you enjoyed the video, and I really hope that you learned something new today. And if you did, please don't forget to give this video a thumbs up and subscribe to my channel if you want to see more similar videos. It really helps.